In this video, let us calculate the speed of water that comes out of a hole in water tank shown. We will assume that hole has cross-section area of A2 and the area of water at tank surface is A1. A word of advice: do not attempt to solve the problem involving fluids with energy conservation equations that is meant for objects, because you will almost definitely get an inaccurate answer, notwithstanding the frustration of trying to solve. In fact, Bernoulli's equation is energy conservation equation that is made simple for fluids, and it really makes things very simple. Now let us get back to the problem. The pressure at surface and at the hole is 1 atmosphere, so we can cancel from both the sides. We now introduce another equation known as continuity equation. It is built on the fact that volume of the incompressible liquid remains constant. After all, the basic property of liquid is that it can change shape, but the volume remains constant. In equation terms, volume of water per second flowing out of the hole should be same as decrease of water volume per second at the surface of the tank. This relates cross-sectional area with velocity. From here, it is simple math. We rearrange the terms in Bernoulli's equation and get this. Substitute the V1 from the continuity equation and get these relationship, which is the answer for the velocity of water flowing out of the hole. We can see that when A1 is very large or A2 is very small, the velocity of water flowing out of the hole reduces to square root of 2gh, which is also known as Torricelli law. Before I end this video, I like to also highlight few things. Firstly, the speed of water flowing out of the hole does not depend upon the shape of the tank. It only depends upon the vertical height h between the two ends. Secondly, as the water flows down the hole, it narrows, and after traveling some distance, it loses streamline flow and becomes turbulent. All this can be seen from the simple water tap, but that will be the subject of another video. That is all for now. Bye bye.